Hello everyone, and so we're starting now on the lesson 24, solutions to systems of linear inequalities with two variables. Alright, so we'll start out with 24.1, a silly riddle. So they start out, let's look at situations of two constraints. Alright, so you're trying to make a quilt, and they're telling you that think of two numbers that add up to 5.678, and the difference, meaning subtraction, between them is 9.876. What's the two numbers? Okay, so I came up with a couple of equations what they're trying to get us towards. All right, name a pair of numbers whose sum is this. So I just did some like 1 plus 4.678, and a pair whose difference is that number. So I said 10.876 minus 1. Alright, so it's just a couple of examples of what would actually solve this. Alright, the riddle can be expressed as two equations. Write the equations. Did that again. And they want us to solve it, so I'll kind of conjoin 3 and 4 together here. So you take these, you add them, the y's cancel, you get 2x is this number. Divide by 2, you get this number. So you know what the x value is. And then you just resubstitute into one of these. I just chose the top one because it's easier for me. So the number you just found plus y is 5.678. And you subtract 7.777 from both sides, and you get the y value. So your x and y value are being represented right there. Okay? So they start out with the quilting project, this next one. They say they need at least 9.5 yards total. And the light color costs $9 a yard. The dark costs $13 a yard. But they don't want to spend more than $110 on this. So they want you to come up with an equation for this. And there are two large graphs that represent the two constraints. So they don't want you to do any work here. I just wrote it here just because it was really convenient for what I was working with. And then just you go to the next page, and they give you the graphs for each one of those. Okay, so this first one is the length constraint, so they have to add up to 9.5. So that's where this little line cuts off here, and here is 9.5. You can either get 0 light fabric and all dark, or all light and no dark. All right, and then this other one is the cost constraint. All right, and so this is what's going on here. All right, so right inequality represents the length. We've got that right here. We just kind of copied it from the other page. Select all pairs that satisfy the length constraint. So if you go through, these have to add up to 9.5, so or more than or equal to 9.5. So 5 plus 5 is 10. 2.5, 4.5 is 7. So that doesn't work. 7.5 and 3.5, that comes up with 11, so that works. 12 and 10, that works too. That's a lot of fabric, but that still works. All right, so that's all this. The ones that work are all in this little blue shaded area. Number 3, they want you to go and write an inequality that represents the cost constraint. So that's this little one over here. All right, and it says, okay, write an inequality. That's that right there. Again, I copied it over from the page before. Select all the pairs that satisfy the cost constraint. So in this one, you come up with $22. This one, you come up with $101. This $110 or $111, which is just over the limit, and then this one it comes up to $103. So we have 1, 2, 3 that will actually hit the cost constraint. So what you have to do is explain why 2 satisfies the cost constraint but not the length. Well, if you get 2 and 2, you add those together, you get 4, and that's obviously not greater than or equal to 9. So you're short on fabric, though you didn't spend a whole lot. Right? But it did match up down here for the cost. I mean, it's hardly any. I mean, it's a very small number, 18 plus 26. So it satisfied the cost constraint but not the length constraint. Number 6, find at least one pair of numbers that satisfies both constraints. Be prepared to explain it. So look up here at the very top, and you can kind of see where you should be looking here. Ultimately, what we want with this is we want to know where they're going to overlap. So I went and took this one and put it over on top of here. I just kind of drew it in. I know it went from 9.5 to 9.5 up there. So I just drew it in. And it kind of gave me an idea here. This little part right in here, that's where the two constraints overlap. Okay, so all this shaded area is everything in the little red lines right here. So this tiny little scalene triangle here, this is like the area that we can work with. So I just got to try to find a little figure that's in there. And I figured that 6, 4 is going to work. So I went and put that in down below. So I said 6 yards of light fabric for the dark. Well, the light costs $9 a yard, so that's 54 bucks. The dark costs 13, so 4 times 13 is 54. You add that up, you get a total of $106. And then when you add up 6 and 4 yards, you come up with 10 yards, so that's just enough. That's over the 9.5. So it works in both instances. So 6, 4 is a good answer for this. What does the pair of numbers represent? It's the yards of light fabric and the yards of dark material, and the units are going to be in yards for each one of them. All right. Now this next one, I'm going to go and just skip it. I don't want you to go back and remember these situations. If you want to go back in your book and look those up for the bank accounts, the concert tickets, and the advertising packages, you can go and look those up. So I'm not going to go and spend a lot of time on here because we've already done it and you can easily look back. So that's not too bad. I want to concentrate more on the actual nuts and bolts of how to do this stuff. Okay. What we're trying to do here is find the intersection of these two graphs. Okay. So in each instance, you're just trying to find where both of them exist, the intersection. Okay. So they start out with something fairly simple here, y greater than 14, so there's a line of 14 and everything above it, that's where y is greater than 14. And then x less than 10, so you have an x value of 10 here and it's everything to the left. Well, the only part where it intersects is this little kind of hash mark area right here. So that's where your solutions are going to be at to satisfy both of these equations. Here, got the same idea. We're going to take each one of these equations, graph them. All right, so you have one in the red that goes all the way over to the right, x is greater than 6, and then everything from that little black dashed line down, that's going to be their solution for the top equation. And this little triangle right here is the one place where they overlap, so that's where your solutions are at. The bottom one, okay, I'm going to graph these two. You'll notice here something unique about this. You have two equations here which have the same slope, but they start at different points. It's as if you took one and just kind of slid it down. Right? So the only place where these overlap is this little tiny little triangle right down here. Right? Now this one is unique because you've got this equation here and you got this equation here. You can rewrite x greater than y as y less than x. And you can graph this, the lower one, this y less than x is down here, or x is greater than y, however you want to think of it. And then this top equation right here. And you'll notice that there's no overlap whatsoever, so there's no solutions. All right, there's no overlap, so no solutions. Okay, you're ready for more? This one's kind of screwy. I'm not exactly sure what they're trying to accomplish here, but let's just go through it here. It says you have two non-negative numbers, x and y, that satisfy x plus y less than or equal to 1. And so I guess it depends on if you're thinking about if you can use decimals, if you can use whole numbers, what do you have available to you. So I'm not exactly sure what they're going at for this. Find a second inequality by using x and y values greater than or equal to 0 to make the system of inequalities with exactly one solution. So the only way I can think of doing something like that is if you had something like this. You start out that you want them both to be positive, which means 0 or more. So I just took this and added 1 to each side. I took this one and I took it to that side. And so the numbers that are going to be adding up are something just that's going to be satisfies both of these. And what you're going to find out is it's somewhere in here. All right, so that's the only thing that you can have. All right, some numbers in this little tiny triangle here between the origin 1, 0 and 0, 1. This little triangle here, that's the only place that you can solve. I'm not exactly sure what they're trying to get at there, so we'll just leave it at that. And they quickly go on to the summary. So the summary is essentially this. You graph your two equations and you find the intersection. That's all you need to do on this. The intersection is the solution to this. Right? So they start out on this one they give you two equations, all right? And then they would say, okay, do the graph, pair things up, see what you got. You know, it's not too difficult. They basically do it for you the next one over, okay? So here's what you've got. The one equation gives you this equation right here. And then the other equation gives you this one right here. And then right here is where they overlap. All right, so they put them both onto the same one finally. And where they both intersect, where they're both lines and kind of gray shaded, that is your solution set right here. That's the solution set. That's the idea here. Okay, so this lesson doesn't do a whole lot other than just explain to you that yes, you look for the intersection. So graph both of them on the same page, on the same chart, and see where they intersect. And that intersection is your solutions. That's all there really is for lesson number 24. We'll be going on to the practice problems next.